Hello students, welcome back to Diksha Vedantu English for 9th and 10th. I'm your chemistry master teacher Ankita. So we are going to discuss topic under 15 minutes. So we will be talking about salts, their preparation and uses. So this is from your second chapter, acids, bases and salts. Of course, grade 10. So what are we going to discuss in this session? We are going to discuss what are the different kinds of salts that we can prepare. How are we going to prepare and their uses. So let's get started without any further ado. So the first thing first, you need to subscribe to the channel for more updates like this, for more videos like this. It's going to be really useful for you. And turn on the notification. And also we have a Telegram channel. So the link will be in the description. Click on that and join our Telegram channel for notes, assignments as well as daily updates. Let's get started without wasting any time. So first one is neutralization reaction. How are we going to obtain salts? By neutralization reaction. So when acids react with bases, they are going to form salt and water along with some heat. Okay, so this is an exothermic reaction. These are nothing but neutralization reaction. For example, HCl will be reacting with NaOH, the classic example, to give NaCl, that is common salt, and H2. Okay, so we know there are different kinds of acids, right? There are strong acids, there are weak acids. So when a strong acid reacts with a strong base, it is going to form a neutral salt. When a strong acid reacts with a weak base, so the acidity is going to overpower the basicity. So acidic salt is formed. And when a weak acid reacts with a strong base, weak acid is reacting with a strong base, what is going to be formed? Basicity is going to overpower the acidity. So a basic salt is formed. What about weak acid and weak base? It depends on the relative strength of the respective acid and the respective base that we are taking in the reaction. Okay. Moving on to acidic salts, examples have given along with the reaction. So ammonia is reacting with HCl. Ammonia is a weak base. So HCl is a strong acid. So we'll get acidic salt, ammonium chloride and water. NH3 when reacts with H2SO4. So we are going to get ammonium sulfate, which is also an acidic salt. And we have basic salts here. CH3COOH is reacting with NaOH. So NaOH is a very strong base. We know that. So strong bases are those which are going to ionize completely in water. Those are called strong bases. Strong acids, so acids that are going to completely dissociate, ionize in water, are called strong acids. On the other hand, weak acids or weak bases are those which are going to partially, incompletely dissociate in water. So example here, basic salts, we have CH3COO in A, sodium salt of acetic acid, and H2CO3. So which is a weak acid. Carbonic acid is going to react with sodium hydroxide to give. So Na2CO3, sodium carbonate along with water. And we have neutral salt. So which is a neutral salt, the most important, most common salt. That is NaCl. That's a neutral salt. So here I have taken other examples. KOH is reacting with H2SO4. So both are equally strong. This is a strong base, strong acid. So K2SO4, potassium sulfate, and NaOH reacting with HNO3, nitric acid, to give NaNO3, sodium nitrate. Okay. So these are examples for neutral salts. Moving on to the very first salt. Common salt. Common salt is nothing but NaCl, sodium chloride. So how do we get sodium chloride? Evaporation of seawater. Seawater is the source of NaCl. The biggest source of NaCl is seawater, and we have, we can extract the salt from earth as well. Okay. So rock salt is brown in color, and as it has some impurities, it will be brown in color. Other impurities, apart from NaCl, there will be other impurities. That's why it's called, rock salt. Evaporation of seawater, so we will get NaCl. So raw material for making many of the substances. What is the use? Apart from using in kitchen as flavoring agents, it is used as flavoring agent. Along with that, apart from that, it is used as a very important raw material in case of making preparing other substances. Let's see how. So the next salt is our caustic soda. Caustic soda is nothing but NaOH, sodium hydroxide. It is an alkali. So what are alkalis? Alkalis are those bases which dissolve in water. These are called alkalis. So when electricity is passed through an aqueous solution of sodium chloride, so a highly concentrated aqueous solution of sodium chloride, the common salt is called brine solution. This is something that you need to remember. So electricity is passed, so it is electrolytic decomposition. It is going to decompose to form sodium hydroxide. Along with sodium hydroxide, we will get chlorine gas as well as hydrogen gas. And this process is called chlor-alkali process. Why the name chlor-alkali? Chlorine will be released and alkali, that is caustic soda, will be produced. That's why it's called chlor-alkali process. Because of the products formed chlor for chlorine, alkali for sodium hydroxide. So chlorine gas is given off at the anodic part of the setup, and hydrogen gas at the cathode. So at the anode, oxidation is going to happen. So at cathode, reduction is going to happen. So chlorine gas is a greenish yellow gas and with a very pungent odor. Hydrogen gas is colorless, odorless, but we have a conformity test for hydrogen gas. When we take a burning matchstick or burning candle near the mouth of the container where the hydrogen gas is evolving, it burns with a pop sound because it's an excellent fuel. Okay, so this is the conformity test. We can easily distinguish between, chlorine as well as hydrogen gas. Sodium hydroxide solution is formed near the cathode. So the three products produced in this process are all useful. These are all useful products. Okay, so this is the reaction here. 2 NaCl reacting with 2 H2O. This is nothing but brine solution, highly concentrated aqueous solution of sodium chloride. So when we pass electricity through this, electrolytic decomposition is going to happen to give caustic soda, chlorine gas as well as hydrogen gas. Moving forward, so what is the use of chlorine gas here? Manufacturing of PVC, polyvinyl chloride, that's plastic, in water treatment, and CFCs, chlorofluorocarbons, and pesticides as well as swimming pools in order to disinfect water. And hydrogen gas is an excellent fuel. So it is used in making margarine, preparation of margarine, and ammonia for fertilizer, NH3. And NaOH, caustic soda, is of immense importance. So it is used in degrazing of metals and in making of soaps and detergents. This is something that we have studied in carbonated compounds and paper making as well as artificial fibers. So these, all the products, the three products from chloralkali process is very, very useful, are very, very useful. Moving on to the bleaching powder. So calcium hypochlorite, what is it called? It is called, let me write here, calcium hypochlorite. The actual composition is quite difficult, the actual structure is quite difficult, but in your syllabus they haven't included the actual difficult, complex structure. It is just calcium hypochlorite or oxychloride. Okay, so how do we prepare this? We have gotten chlorine gas from chloralkali process, right, or any other process. So chlorine gas is used for the manufacture of bleaching powder. Bleaching powder is produced by the action of chlorine on dry slake lime, that is calcium hydroxide. So bleaching powder is represented as calcium hypochlorite, though the actual composition is quite complex, as I already mentioned. So calcium hydroxide is made to react with chlorine gas to give calcium hypochlorite and water. This is the reaction. So whenever in the exam they ask you to write the preparation or explain the preparation of a certain salt, you have to make sure to write the balanced equation. Okay, so I have made a 15-minute video, actually 11-minute video, 12-minute video on how to balance the chemical equation. Go check that out. And what are the uses of this bleaching powder? So it is used for bleaching cotton and linen in the textile industry in order to remove the colors, okay, or stains. So for bleaching wood pulp in paper factories and for bleaching washed clothes in laundry. It is used as an oxidizing agent in many chemical industry. Okay, it's a very good oxidizing agent. And to make drinking water free from germs. This calcium hypochlorite of bleaching powder releases chlorine when it is mixed in water. That's why it is used as a disinfectant. Moving on to the next one, baking soda, NaHCO3. What is it called? Sodium bicarbonate or sodium hydrogen carbonate. Either is fine. Sodium bicarbonate. Okay. So how do we prepare this? So the chemical name of the compound is sodium hydrogen carbonate or sodium bicarbonate. So it is produced using sodium chloride as one of the raw materials. This is also called solvay ammonia process. What do we do here? We take brine solution again. So highly concentrated aqueous solution of sodium chloride will be taken. It will be introduced into a carbonating tower. So in carbonating tower, we'll have carbon dioxide gas. So this brine solution is going to react with carbon dioxide, and this mixture will be made to react with ammonia. That's why the name solvay ammonia process. Solvay was the scientist. Okay, so we are going to get NaHCO3, that is sodium bicarbonate, along with NH4Cl. So NH4Cl is nothing but ammonium chloride, which is a byproduct of solvay ammonia process. When we talk about uses of sodium bicarbonate, so for making baking powder, which is a mixture of baking soda and mild edible acids such as tartaric acid. So we use baking powder, right? So baking powder has baking soda along with a mild edible acid, and when baking powder is heated and or mixed in water, this reaction takes place. This is a very important reaction. So H plus ion is given by the mild edible acid. Okay, NaHCO3 plus H plus gives carbon dioxide and H2O. This carbon dioxide that is released is responsible for fluffiness of the cake. Okay, and it is also an ingredient in antacids. Antacids are those which are used to neutralize the acid in the stomach. When we have acidity, we use antacids. So along with magnesium hydroxide, which is one of the most important antacids, we are going to use baking soda as well. So being alkaline, it neutralizes excess acid in the stomach and provides relief. It is also used in soda acid fire extinguisher. In soda acid fire extinguisher, we are going to have H2SO4 and baking soda. So when we press the knob, when there is fire, we press the knob. So then the containers having H2SO4 and NaHCO3 are going to open up. They are going to react with each other. We know in the same chapter that acids are going to react with metal carbonates or bicarbonates to give carbon dioxide gas, right? Carbon dioxide gas is used to put out the fire. Okay, so that's how baking soda is used in soda acid fire extinguisher. Next, so we have the next salt, washing soda. This is sodium carbonate 10H2O, decahydrate. Here 10H2O is the water of crystallization. Okay, so it is the integral part of the crystalline structure. So how do we prepare this? Very simple. So we are going to heat sodium bicarbonate, that is baking soda, and we are going to get sodium carbonate, water and carbon dioxide gas. This sodium carbonate that is produced is going to be made to react with water, 10 molecules of water. So it becomes washing soda. So Na2CO3, 10H2O. So this is nothing but sodium, I'll write here sodium carbonate decahydrate. Sodium carbonate decahydrate. Decahydrate. Okay. So where do we use this? Sodium carbonate is used in glass, soap and paper industries in manufacturing of these things, and it is used in the manufacture of sodium compounds such as borax. And also sodium carbonate can be used as a cleaning agent for domestic purpose. It is used for removing permanent hardness of water. Soaps are not useful in hard water, okay, but these are useful in hard water. Moving on to the next one, plaster of Paris, calcium sulfate hemihydrate. Hemi, half. So calcium sulfate, I'll write here hemihydrate. Hemihydrate. You might be wondering how half molecule of water of crystallization. So 2 calcium sulfate molecules are going to share 1 molecule of water. That's why we have half H2O. So calcium sulfate hemihydrate. So how do we prepare that? So we extract gypsum, okay, from earth. So on heating gypsum is nothing but calcium sulfate dihydrate, CaSO4 2H2O. So at 373 Kelvin, it loses water molecules and becomes calcium sulfate hemihydrate. Okay, so this is a powdery substance. But so as soon as it loses water, so it's the other way around. So it is it is a solid mass, hard solid mass, and when it loses water of crystallization, it is going to become powdery substance. Plaster of Paris is powdery substance. Where do we make use of this? So it is used in supporting fractured bones by the doctors, casting, and used as fireproof materials in building as it is fire resistant. So it won't catch fire, so it is used in buildings as well as architectural designs, and used to make sculptures as well as toys. Okay, yeah, these are heavy, but these increases the beauty of sculptures. Moving on to the next one. That's it. We are done with all the salts from the chapter 2, acids, bases and salts. For more videos like this, please do subscribe to the channel and turn on the notifications. And thank you. All the best.